In this video, we will derive Lax-Wendroff method using a slope scheme. So for Lax-Wendroff method, the sigma ni, which is a slope is written as qni plus 1 minus qni divided by delta x. And similarly, the slope for the case when we have I minus 1, then we have sigma. This is sigma, which is slope. Sigma n I minus 1 is equal to qn I minus qn I minus 1 divided by delta x. We put these two values over here. So we have the numerical method in terms of slope. Qn plus 1 I is equal to qn I minus u bar delta t by delta x qni minus qn I minus 1 minus 1 by 2 u bar delta t by delta x. Then we have delta x minus u bar delta t. And this term, the green color, will become sigma. I'm sorry, it is not sigma, q n I plus 1 minus q n I divided by delta x minus, and we have q n I minus q n I minus 1 divided by delta x. Okay, so what we do now, we just need to find out the formula for Lax-Wendroff method and its particular form over here. So first of all, we just have to write all the terms again. qni minus u bar delta t by delta x, qni minus qni minus 1 minus u bar delta t by delta x, and delta x minus u bar delta t, and this term will be equal to delta x qni plus 1 minus 2qni plus qni minus 1. So what we do, we now multiply these together. qni minus u bar delta t by delta x, qni minus qni minus 1 minus u bar delta t by delta x, and we just need to multiply these two terms first. So we get delta x, then multiply the green color, and the green color becomes qni plus 1 minus 2qni plus qni minus 1 divided by delta x over here. And we do the same for the second term. For this case, we have, for example, the first, this minus minus becomes plus. So we have plus, then we have u bar delta t square divided by delta x, which is square, and then we have u square. And delta x square becomes due to this term over here. So we have qni plus 1 minus 2qni plus qni minus 1. Next, we just need to add these two terms as we did earlier for beam warming method. So we have qni minus, we take a common u bar delta t by delta x. Then we have, for example, this will be cancelled out, or either you can cancel these two terms, or either you can cancel these two terms, these two terms. So it remains the same. The procedure remains the same. So the green, the first one is the white color, q and I minus q and I minus 1 minus q and I plus 1 plus, so I should write this as minus q and I plus 1 plus 2q and I, and we also have probably okay, if we take minus as a common, then qn minus 1, so this is plus, so we have plus over here, then we have minus over here, minus 2q and I, then we have plus q and I minus 1. Okay, divided by, is there any division? No, there is no division. So we have probably, there should be 2 as well, I guess. So we have 2 over here. This is 2. So we have probably 2q and 2q and I, and we also have minus 2q and I minus 1 due to this minus, so on. Only this is algebraic thing that you can correct it yourself. Plus, and the last term is u bar, and there is 1 by 2 as well. So yes, there is 2. 1 by 2 u bar delta t by delta x whole square, and we have q and I plus 1 minus 2q and I plus q and I minus 1. Now it's a matter of simplification. Q and I minus u bar delta t by 2 delta x. There should be 2 as well. 2 delta x. 2q and I will be cancelled out. This is cancelled. And what we have, q and I plus 1. Q and I plus 1 minus, or it should be plus 1 minus q and I minus 1. It is correct. Plus 1 by 2 u bar delta t by delta x whole square, and we have q and I plus 1 minus 2q and I plus q and I minus 1. So this is the formula for Lax-Wendroff method. Lax-Wendroff method for the advection equation. Wendroff method for the advection equation. For the vector form, you should put a over here, and this becomes a square, so on. Thank you for watching.